Hello everyone. In this lecture we discuss numerical problems related to electrochemistry. Electrochemistry. First problem is calculate the electrode potential or EMF. Electrode potential of the following electrodes. Of the following electrodes of the following electrodes at 298 Kelvin temperature. Okay. In this numerical problem, we calculate the electrode potential at 298 Kelvin temperature. First cell reaction is Zn2 plus in aqueous solution 0.1 molar of zinc electrode Zn solid. Okay. For this cell reaction, standard electrode potential is Zn is equal to minus 0.761 volt. This value is given to us in this cell reaction. Firstly, write down the cell reactions. Here Zn2 plus, that is here gaining of electron, therefore reduction takes place. Then we can write the reduction reaction for this cell. Zn2 plus 2 electron to give zinc electrode, that is Zns. This is cell reaction. For this, firstly we calculate reaction quotient Q and then this Q value put up in Nernst equation. Therefore we get EMF of this or electrode potential of the following electrodes. Okay. First write down reaction quotient Q. Q is equal to activity of Zn upon activity of Zn2 plus. Okay. For this, activity of Zn is nothing but 1 upon activity of Zn2 plus. Okay. Now we calculate the value. We calculate the value of this cell reaction, that is EMF, using Nernst equation. Firstly write down the Nernst equation. What is Nernst equation? Nernst equation is E is equal to E naught cell is equal to, or E cell is equal to E naught cell. Cell is here Zn, then we can write E Zn upon E Zn, E naught Zn minus 2.303 RT/NF log of reaction quotient Q to the base 10. Okay. Now the value of E naught Zn is given to us. The value of N, that is number of electrons in this cell reaction, is participate is 2, and the reaction quotient Q values already we can find out. Then put up this value. E naught Zn is equal to 0. minus 0.761 given to us minus 2.303 RT, the value of RT upon 2F into log of the value of 1 upon activity of Zn 2 plus 1 upon activity of Zn 2 plus. Okay, and the concentration for Zn 2 plus ions given in the cell reaction is 0.1 molar, that is 0.761 minus 2.303 RT to F minus 2.303 RT upon 2F into log of 1 upon activity of Zn2 plus. The value is given to us in cell reaction, that is concentration of activity of Zn2 plus is 0.1. Therefore we can write 1 upon 0.1 to the base 10. Okay, next is this value at 298 Kelvin temperature. We can write here at 298 Kelvin temperature the value becomes minus 0.761 minus 0.0591 into the value of log of 1 upon 0.1 is converted as to as it is, and this value converted to 0.0591 into log of 10, and this value, this dividation, the value becomes 10, log of 10. Okay, next is minus 0.761 minus, when dividing this value to dividing to the 0.0591, the value becomes 0.02955. Okay, into log of 10 to the base 10. Okay, and the value of log 10 is equal to 1. Therefore value becomes minus 0.761 minus 0.02955. Okay, and this minus get plus, therefore value, last value 0.07905 volt, because the EMF unit is volt, and this is the electrode potential of this cell is minus 0.79055 volt. In this way we can calculate electrode potential to any cell reaction. Okay, this is first example. Next example is same as it is, the only difference is the cell reaction. Next cell reaction is, here write down AgCl. Next example is AgCl electrode to give, the cell is Cl minus aqueous solution, activity A is equal to 0.01 AgCl and Ag electrode. Okay, this is cell. For this cell, firstly we can write the cell reaction. Here the reduction potential takes place, therefore reduction reaction takes place, then the reaction becomes, here write down cell reaction, AgCl plus 1 electron, that is gaining of electron, to gives Ag plus Cl minus, Ag plus Cl minus in aqueous. Okay, for this firstly we can write the reaction quotient Q. Q is equal to this value Ag and AgCl of activity, or concentration of AgCl and Ag becomes 1. We all know that. Therefore only here concentration of Cl minus, that is activity of Cl minus. Okay, this is reaction question for QA for this cell reaction. Now this value put up in Nernst equation, and the Nernst equation is E cell. Here cell is AgCl is equal to E naught of AgCl minus 2.303 RT NF log of reaction quotient QA to the base 10. Okay, now the value, put up this value in this equation, that is E naught AgCl, the value in EMF series, this is the standard values in EMF series. Therefore this value is 0.233 minus 2.303 RT. N is becomes 1, that is number of electrons, here 1. Therefore only write 2.303 RT upon F into log of reaction quotient Q is equal to activity of Cl minus to the base 10. Okay, next is this value becomes converted to 0.0591 at 298 Kelvin temperature. Here write down E cell of AgCl is equal to 0.223 minus 2.303 RT upon F is converted to 0.0591 into log of 10, and activity of Cl minus is equal to, we have to given, that is 0.01 molar. Here we write down into log of 10, 0.01 molar. Okay, next is log of 0.01 becomes, the value is 2. Therefore put up this value 0.223 minus 0.0591 into value is 2. Okay, when multiplying this 2 into 0.0591, the value becomes 0.223 minus the value is -2, sorry, log of 10 of 0.01, the value is -2. Therefore, when multiplying this, the value becomes plus, and the value is 0.1182. When combining this value, we get 0.3412 volt. This is the electrode potential for this cell reaction, or this value is 0.3412 volt. Okay, these are the two problems related to when in exam asking the question in this type, solve this example as it is. Therefore, you get out of out marks in exam. Firstly, write the reaction and then calculate reaction quotient, and then this reaction quotient is put up in the Nernst equation to get EMF of this cell or electrode potential of this cell. Okay, next example is calculate EMF of the cell at 298 Kelvin temperature. This is cell reaction. From this cell reaction, we conclude that here two electrodes are same, only difference is pressure or concentration. Here 0.5 atmospheric pressure, and in this electrode 3 atmospheric pressure. These two electrodes are dipped in one electrolyte solution. Therefore, this type of cell reaction is called as electrode concentration cell without transference, because here only one electrolyte solution is present. Therefore, we can call it is electrode concentration cell without transference. Okay, for without transference, the EMF is calculated by using this equation. Directly we can write E cell, that is here cell is platinum chlorine electrode, and the E cell is given to us. E cell is equal to 2.303 RT upon 2F into log of P2 by P1 to the base 10. Okay, at 298 Kelvin temperature, the value becomes converted as 0.0591 upon 2 because here 2 electrons are present, into log of P2 pressure, that is here second electrode is 3 atmospheric pressure. We can write 3 upon P1 is equal to 0.5 atmospheric pressure. Okay, and the value becomes converted as, when dividing these two, the value is 0.02955 into log of 6 to the base 10. When put up the value of log 6 and multiplying this value to this, we can get value is 2299 volt. This is value of EMF of this cell. This equation we can write down directly, because we all know that the equation for electrode concentration cell without transference. Therefore, we can write directly this equation and put up this value and calculate the EMF of cell for this reaction. Okay, This is the numerical problem related to this. Next example is in next lecture we can काय सांगू Okay, these are some example related to electrochemistry. One by one in next lecture we discuss another some problem related to electrochemistry. Okay, thank you.